The darkness of October 25, 1944 stretched across Leyte Gulf like a black curtain. Seaman First Class Tommy Martinez pressed his face against the cold steel of USS Washington's forward fire control station. The massive battleship cut through Pacific waters at 18 knots. Her 16-inch guns pointed toward an enemy that could not see what was coming. Martinez had been aboard USS Washington for 8 months. The South Dakota-class battleship carried a crew of 2,500 men. Her main battery consisted of 9 16-inch guns arranged in 3 turrets. But tonight the real weapon was something the Japanese Navy had never encountered. The SG surface search radar mounted high on Washington's superstructure could detect enemy ships at 20 miles in complete darkness. Fire Controlman Second Class Robert Chun monitored the Mark 8 fire control radar from his position in the main battery plotting room. The green sweep on his radar scope painted a picture no human eye could see. 3 enemy heavy cruisers approached from the northwest at 15,000 yards. Behind them came 2 more vessels. The Japanese task force steamed directly toward the American landing force at Leyte Gulf. Admiral Willis Lee commanded Task Force 34 from USS Washington's bridge. The admiral had handpicked this battleship group for tonight's mission. Washington carried the most advanced fire control system in the Pacific Fleet. Her Mark 7 fire control computer could calculate firing solutions while both ships maneuvered at high speed. Japanese naval doctrine still relied on visual spotting and manual gun laying. They had no idea American ships could engage targets beyond visual range. Chief Petty Officer Mike Sullivan supervised the 5-inch gun crews on Washington's port side. The twin-mount 5-inch 38 caliber guns served as the ship's secondary battery. Each gun could fire 22 rounds per minute. Tonight they would demonstrate something that would shock the Imperial Japanese Navy. The Mark 37 gun director linked every 5-inch mount to centralized radar fire control. 1 radar operator could direct all 10 5-inch guns simultaneously. Martinez felt the deck vibrate as Washington's propeller shafts spun faster. The ship accelerated to battle speed. Through his headphones came the voice of Lieutenant Commander James Harrison from the Combat Information Center. The CIC represented a revolution in naval warfare. Banks of radar scopes and plotting tables gave the ship's commanders a complete picture of the tactical situation. Japanese cruisers still fought from their bridges using optical rangefinders and voice communications. The enemy task force closed to 12,000 yards. Japanese Admiral Kurita commanded the heavy cruisers Takao, Maya, and Otago. These ships displaced 13,000 tons each and carried 10 8-inch guns. Their crews were veterans of dozens of surface actions. They had fought at the Java Sea, Midway, and Guadalcanal. But they had never faced radar-controlled gunfire. Radar operator First Class David Kim tracked the Japanese formation from his position in Washington's CIC. The N/SG-6 surface search radar painted the enemy ships as bright green blips on his scope. Range 11,500 yards and closing. The Japanese cruisers maintained formation in line ahead. Their optical rangefinders could not penetrate the moonless night. They steamed blind toward the most powerful battleship in the Pacific Fleet. Lieutenant Commander Harrison studied the tactical display. Washington's radar had first detected the Japanese ships at 18,000 yards. For the past 20 minutes, the American battleship had tracked every movement of the enemy formation. The Japanese had no idea they were being observed. This technological advantage would prove decisive in the coming battle. Gun Director Operator Second Class Frank Torres sat at the controls of the Mark 37, director for Mount 52. The director's radar antenna rotated smoothly as it tracked the lead Japanese cruiser. Range 10,000 yards. Bearing 315 degrees relative. The fire control computer continuously calculated the target's course and speed. When Washington opened fire, every shell would be aimed by radar and computer. The 5-inch guns represented only part of Washington's firepower advantage. Her 3 16-inch turrets carried the Mark 8 fire control radar. These massive guns could engage targets at 23,000 yards. Japanese heavy cruisers mounted armor designed to stop 8-inch shells. Washington's 16-inch armor-piercing projectiles weighed 2,700 pounds each. They could penetrate 32 inches of steel armor at 10,000 yards. Turret Captain 3rd Class Antonio Rodriguez commanded Washington's No. 216-inch turret. The turret's 3 guns could fire a 2,700-pound shell every 30 seconds. Each projectile contained 40 pounds of explosive filler. When these shells struck a Japanese cruiser, the results would be catastrophic. Rodriguez and his crew had trained for 2 years on radar-directed night firing. Tonight, they would put that training to use. Fire Control Officer Lieutenant William Thompson coordinated Washington's gunnery from the main battery plotting room. Banks of analog computers calculated firing solutions for both the 16-inch and 5-inch batteries. The Mark 8 radar could track multiple targets simultaneously. Thompson could engage 3 enemy ships at once while maintaining accurate fire on all targets. The Japanese cruiser formation closed to 8,000 yards. Still no indication they had detected Washington's presence. Japanese lookouts strained their eyes searching for American ships. Their optical equipment was useless in the darkness. Meanwhile, Washington's radar operators watched every move the enemy made. The technological gap between the two navies had never been more apparent. Chief Gunner's Mate Carlos Williams supervised the ammunition handling crews deep in Washington's magazines. The ship carried 1,200 rounds of 16-inch ammunition. Each armor-piercing shell was machined to precise tolerances. The explosive filler was mixed to exact specifications. These projectiles represented the finest naval ammunition ever manufactured. They would prove their worth in the next few minutes. Admiral Lee made his decision. At 0347 hours, he ordered Washington to open fire. The massive battleship would demonstrate the revolution that radar fire control had brought to naval warfare. Japanese cruisers approaching in the darkness had no chance against computer-controlled guns guided by radar. The age of visual gunnery was about to end forever. Fire control radar operator 1st Class Stephen Park centered his crosshairs on the lead Japanese cruiser. The Mark 8 radar painted a sharp return at 7,500 yards. Course 140 degrees. Speed 18 knots. The fire control computer digested this information and calculated the exact firing solution. Park pressed the firing key. 3 16-inch guns roared in unison. The muzzle flash from Washington's main battery illuminated the night sky. For a split second, the darkness vanished in a burst of orange flame. Then blackness returned. The 3 2,700-pound shells raced through the air at 2,500 feet per second. Flight time to target was 18 seconds. The shells followed a ballistic trajectory calculated by radar and computer. Japanese lookouts aboard the cruiser Takao spotted the muzzle flash 7,500 yards to the southeast. They immediately sounded the alarm. Battle stations. Enemy battleship bearing 135 degrees. But it was too late. The American shells were already in the air. Takao's crew had no time to maneuver or return fire. The first 16-inch shell struck Takao's forward superstructure. The 2,700-pound projectile punched through 6 inches of steel armor as if it were paper. The shell exploded inside the cruiser's combat information center. 40 pounds of high explosive vaporized everything within 30 feet. The blast killed every man in the compartment instantly. The second shell hit Takao amidships. It penetrated the engine room bulkhead and exploded among the high-pressure steam lines. Superheated steam at 800 degrees filled the compartment. Men caught in the blast were scalded to death in seconds. The explosion ruptured the main steam line to the port engine. Takao's speed dropped to 12 knots. The third shell struck Takao's after turret. The 16-inch projectile penetrated the turret's 8-inch armor and detonated in the handling room. The explosion ignited 200 rounds of 8-inch ammunition. Secondary explosions ripped through the stern of the ship. Takao's after section erupted in a column of flame that rose 500 feet above the water. Radar operator Kim watched the Japanese formation on his scope. The lead cruiser had stopped maneuvering. Her speed dropped to 8 knots. The second and third cruisers maintained course toward Washington. Range 6,000 yards. They had not yet opened fire. Their optical rangefinders could not locate the American battleship in the darkness. Lieutenant Commander Harrison coordinated the engagement from Washington's CIC. The ship's radar picture showed complete dominance over the enemy. Japanese cruisers were blind in the night battle. They could only fire at muzzle flashes. Washington could engage multiple targets with radar-directed fire while remaining nearly invisible to the enemy. Gun Director Operator Torres locked his Mark 37 Director onto the second Japanese cruiser. The Maya-class heavy cruiser displaced 13,000 tons and carried 10 8-inch guns. Her crew was turning to starboard trying to unmask their main battery. Torres centered his crosshairs on the cruiser's superstructure. Range 5,800 yards. Bearing 320 degrees. He pressed the firing key for all 10 5-inch guns. The 5-inch battery opened fire in unison. 10 guns firing at 22 rounds per minute created a steady stream of projectiles. Each 54-pound shell contained 7 pounds of high explosive. The Mark 37 fire control system adjusted aim automatically as both ships maneuvered. Every round was guided by radar to its target. The first salvo of 5-inch shells bracketed the Japanese cruiser Maya. Geysers of water erupted around the ship as shells struck the sea. The radar fire control system made corrections automatically. The second salvo hit the target. 10 54-pound shells exploded across Maya's superstructure. The cruiser's bridge disappeared in a cloud of smoke and flame. Maya's captain was killed instantly when a 5-inch shell exploded in the wheelhouse. The ship's senior officers died with him. With her command structure destroyed, Maya began turning in circles. Her rudder jammed hard over to port. The cruiser presented a perfect target for Washington's main battery. Turret Captain Rodriguez traversed his 16-inch guns toward the circling Japanese cruiser. The Mark 8 fire control radar tracked Maya's erratic movements. The computer calculated a new firing solution every 2 seconds. At 5,000 yards range, the American shells could not miss. Rodriguez ordered his crew to load armor-piercing rounds. The 3 16-inch guns fired again. This time the target was the crippled Maya. Her circular course made her an easy target for radar-controlled guns. The shells struck the cruiser's engineering spaces. 2 2,700-pound projectiles penetrated deep into the ship before exploding. The blast tore a 60-foot hole in Maya's starboard side. Water rushed into Maya's engine rooms through the massive hole. The cruiser listed 15 degrees to starboard. Her remaining boilers lost pressure as seawater flooded the fireboxes. Maya's speed dropped to 6 knots. She was dead in the water and sinking rapidly. The third Japanese cruiser, Atago, finally opened fire. Her 8-inch guns flashed in the darkness 4,500 yards from Washington. The Japanese gunners aimed at the American battleship's muzzle flashes. Their shells followed high arcing trajectories toward the target. But without radar fire control, the Japanese could only guess at range and bearing. Atago's first salvo fell 1,000 yards short of Washington. The 250-pound shells exploded harmlessly in the water. Geysers of spray rose around the American battleship but caused no damage. The Japanese cruiser's optical rangefinders could not determine the exact range to target in the darkness. Chief Sullivan watched the enemy shells land short of Washington. The 5-inch gun crews cheered as the Japanese salvos fell harmlessly into the sea. American radar fire control gave Washington a decisive advantage. She could engage the enemy with precision while remaining nearly invisible to their optical equipment. Lieutenant Thompson adjusted Washington's fire to the new target. Atago was the last operational Japanese cruiser. Her destruction would complete the annihilation of Admiral Kurita's task force. The Mark 8 radar locked onto the enemy ship at 4,200 yards range. The fire control computer calculated a solution for both the 16-inch and 5-inch batteries. Washington's guns fired in succession. First, the 5-inch battery engaged Atago's superstructure. 20 shells per minute struck the Japanese cruiser's command and control centers. Then the 16-inch guns fired their devastating salvo. 3 2,700-pound shells tracked toward the target guided by radar and computer. Atago's forward turret exploded when a 16-inch shell penetrated its ammunition magazine. The blast vaporized 150 rounds of 8-inch shells. The explosion broke the cruiser's back. Her hull cracked amidships. Both sections of the ship began sinking immediately. The Japanese task force was completely destroyed. Takao burned from stern to stern. Maya had capsized and disappeared beneath the waves. Otago broke in half and sank within minutes. Washington's radar-controlled guns had accomplished in 20 minutes what might have taken hours of daylight fighting. Radar operator Kim observed the aftermath on his scope. 3 large contacts had vanished from the screen. Only small blips remained marking lifeboats and debris. The Japanese cruiser force had been eliminated without inflicting a single casualty on Washington. Radar fire control had revolutionized naval warfare overnight. Admiral Lee surveyed the battle from Washington's bridge. The American battleship had demonstrated the overwhelming advantage of radar-guided guns in night fighting. Japanese naval doctrine emphasized close-range combat using visual spotting. They had no answer to long-range radar-directed fire. The Imperial Navy's surface fleet was suddenly obsolete. Seaman Martinez climbed topside to observe the battle's aftermath. Fires burned on the horizon where Japanese ships had died. Oil slicks spread across the dark water. Hundreds of Japanese sailors floated in life jackets waiting for rescue. The technological advantage had been complete and decisive. The victory at Leyte Gulf marked a turning point in Pacific naval warfare. American radar fire control systems had proved their devastating effectiveness against Japanese surface forces. Future night battles would be one-sided affairs. The Imperial Navy could no longer challenge American warships in darkness. Gun crews aboard Washington secured their weapons as the battleship resumed course toward the landing beaches. The ship's 16-inch and 5-inch guns had fired 150 rounds during the engagement. Every shot had been aimed by radar and guided by computer. The age of visual naval gunnery was ending. Chief Williams supervised the replenishment of Washington's magazines. The ship's ammunition consumption had been modest considering the destruction inflicted. Radar fire control allowed precise shooting that minimized waste. Japanese cruisers had been destroyed with surgical accuracy. Fire Control Officer Thompson compiled his battle report for Admiral Lee. Washington had engaged 3 enemy heavy cruisers at ranges between 400 and 800 yards. All targets had been destroyed within 20 minutes. The American battleship suffered no damage and no casualties. Radar-controlled gunnery had achieved perfect results. The Japanese survivors floating in Leyte Gulf could not comprehend what had happened to their ships. The enemy had fired with impossible accuracy in complete darkness. Their cruisers had been hit repeatedly by shells that seemed guided by supernatural forces. They did not understand that American radar technology had made their deaths inevitable. Radar operator Park secured his equipment as Washington withdrew from the battle area. The Mark 8 fire control radar had performed flawlessly during the engagement. Every target acquired had been destroyed. The system represented a quantum leap forward in naval technology that the Japanese could not match. Lieutenant Commander Harrison analyzed the tactical situation from the CIC. American radar equipment had provided complete dominance over Japanese forces trained in traditional naval warfare. The enemy had fought courageously, but their optical fire control systems were useless in darkness. Technology had overcome valor. Turret Captain Rodriguez supervised the cleaning of his 16-inch guns. The massive weapons had fired 18 rounds during the battle. Each shell had been aimed by radar at an invisible target. The accuracy achieved was impossible with visual fire control methods. American battleships now ruled the night. The destruction of Admiral Kurita's cruiser force sent shockwaves through the Imperial Japanese Navy. Their most experienced surface commanders had been eliminated by an enemy they could not see or effectively engage. American radar technology had achieved what seemed impossible just 2 years earlier. Washington's victory demonstrated the revolution that electronics had brought to naval warfare. Radar detection and fire control systems gave American ships overwhelming advantages in night fighting. Japanese naval doctrine emphasized skill and fighting spirit. But technology had made these qualities irrelevant. Chief Sullivan addressed his 5-inch gun crews as Washington steamed toward the transport area. The men had witnessed the future of naval combat. Radar-guided guns could destroy enemy ships with precision that amazed even experienced gunners. The American technological advantage was complete and decisive. Martinez watched the sun rise over Leyte Gulf on October 26, 1944. The previous night had demonstrated American naval supremacy in the starkest possible terms. Japanese surface forces could no longer challenge radar-equipped battleships. The Pacific War had reached a technological tipping point. The battle's impact extended far beyond the destruction of 3 Japanese cruisers. Admiral Kurita's defeat convinced many in the Imperial Navy that conventional surface warfare was futile against American radar technology. Future Japanese naval operations would rely increasingly on suicide attacks and unconventional tactics. Washington's crew took pride in their technological superiority over the enemy. The ship's radar systems and fire control computers represented the finest military technology ever developed. American industrial capacity had produced weapons that gave decisive advantages to U.S. Navy forces throughout the Pacific. The engagement also demonstrated the importance of training and doctrine in exploiting technological advantages. Washington's crew had drilled extensively on radar fire control procedures. Their proficiency allowed maximum effectiveness from the advanced equipment. Technology alone was not sufficient without proper training. Gun Director Operator Torres reflected on the night's events as Washington approached the landing area. His Mark 37 director had guided every 5-inch shell to its target with computer precision. The Japanese had no equivalent system. Their guns were aimed manually using optical sights that could not function in darkness. Japanese naval intelligence struggled to understand the American technological breakthrough. Reports from survivors described impossible shooting accuracy in complete darkness. The Imperial Navy had no countermeasures for radar-controlled guns. Their surface fleet was suddenly obsolete and vulnerable. Admiral Lee prepared his action report for Pacific Fleet headquarters. Washington had demonstrated the decisive advantage of radar fire control in night surface actions. American battleships and cruisers equipped with these systems could destroy enemy forces with minimal risk. The technological revolution was complete. The victory at Leyte Gulf also showcased American manufacturing superiority. Washington's radar equipment represented thousands of hours of engineering work and millions of dollars in research and development. The United States had built a technological advantage that Japan could not match or counter. Fire Controlman Chun secured his radar equipment as Washington anchored off the landing beaches. The Mark 8 fire control system had tracked multiple targets simultaneously while computing accurate firing solutions. Japanese ships had been destroyed with mathematical precision. Human skill could not compete with electronic calculation. The psychological impact on Japanese naval personnel was severe. Their most modern cruisers had been destroyed by an invisible enemy. Traditional naval tactics were useless against radar-controlled guns. Many Japanese officers began to question whether conventional surface warfare remained viable. Washington's ammunition expenditure during the battle was remarkably efficient. The ship had fired 45 rounds of 16-inch ammunition and 105 rounds of 5-inch shells. This modest consumption had eliminated 3 heavy cruisers totaling 39,000 tons. Radar fire control achieved maximum destruction with minimum waste. Chief Petty Officer Martinez climbed to Washington's signal bridge to observe the landing operations. Hundreds of American ships filled Leyte Gulf. The successful night battle had eliminated the last serious threat to the invasion force. Japanese surface vessels could no longer challenge American naval supremacy. The technological lessons from Leyte Gulf spread rapidly through the Pacific Fleet. Every American warship would eventually receive radar fire control systems. The advantages demonstrated by Washington became standard equipment throughout the Navy. Japanese forces would face this overwhelming technological superiority in every future engagement. Lieutenant Thompson completed his detailed analysis of the battle's gunnery performance. Washington had achieved a hit percentage of 78% with her main battery and 65% with the 5-inch guns. These figures were impossible to achieve with optical fire control systems. Radar technology had revolutionized naval accuracy. Japanese Admiral Kurita survived the destruction of his cruiser force by transferring to a destroyer before the battle. His report to Combined Fleet Headquarters described the hopeless situation facing Japanese surface ships. American radar equipment made night fighting impossible for conventionally equipped vessels. The battle also demonstrated American superiority in damage control and ship design. Washington absorbed several near misses from Japanese shells without suffering significant damage. Her compartmentalization and armor protection proved superior to Japanese cruiser construction. American shipbuilding technology matched the electronics revolution. Radar operator Kim prepared his equipment status report as Washington secured from general quarters. All radar systems had functioned perfectly during the engagement. The technology that seemed magical to Japanese observers was becoming routine for American crews. Training and equipment combined to create decisive advantages. The destruction of the Japanese cruiser force at Leyte Gulf marked the end of the Imperial Navy as an effective surface fighting force. Remaining Japanese ships would avoid night engagements with American radar-equipped vessels. The technological advantage was too great to overcome with traditional tactics. Washington's victory validated years of American investment in radar development and fire control systems. The Massachusetts Institute of Technology Radiation Laboratory had produced the technology that gave American ships overwhelming advantages. Science and engineering had won the battle before the first shot was fired. Gun crews throughout Washington discussed the night's remarkable shooting performance. Veterans of earlier battles had never seen such accurate fire in darkness. The radar-guided guns had hit targets that were completely invisible to human observers. Technology had transformed naval warfare fundamentally. Chief Williams supervised the inventory of Washington's remaining ammunition. The ship retained more than 90% of her original load despite destroying 3 enemy cruisers. Radar fire control eliminated the wasteful shooting that characterized earlier naval battles. Precision replaced volume as the key to gunnery success. The tactical implications of radar-controlled guns extended beyond night fighting. American ships could engage targets at extreme ranges in any weather conditions. Japanese naval doctrine emphasized close-range combat where their superior torpedo armament might prove decisive. Radar technology made close engagement unnecessary and dangerous. Fire Control Officer Thompson briefed Washington's junior officers on the battle's lessons. Radar fire control systems required extensive training and maintenance but provided unprecedented capabilities. American technological superiority would only increase as more advanced equipment entered service. Japanese naval aviation received reports of the cruiser force destruction with dismay. Surface ships could no longer provide effective anti-aircraft protection for naval task forces. American radar-equipped vessels could destroy Japanese escorts before air attacks developed. The entire structure of Japanese naval operations was crumbling. Martinez observed the controlled chaos of amphibious operations as Washington provided fire support for landing forces. The battleship's 16-inch guns could engage targets miles inland using radar spotting and computer-controlled fire. Japanese defensive positions had no sanctuary from American technological superiority. The psychological impact of the Leyte Gulf night battle spread throughout the Japanese fleet. Sailors who had served on modern cruisers understood that their ships were defenseless against radar-controlled guns. Morale declined as the hopelessness of conventional naval combat became apparent. Washington's crew took justifiable pride in their role in demonstrating American technological supremacy. The ship had proved that radar fire control systems could dominate any surface engagement. Japanese naval forces would avoid night battles for the remainder of the war. The revolution was complete and irreversible. Admiral Lee's action report reached Admiral Nimitz at Pearl Harbor within 48 hours. Pacific Fleet commanders immediately recognized the significance of Washington's victory. Radar-controlled gunnery had eliminated Japanese surface forces as a strategic threat. American naval supremacy was now technologically guaranteed. The battle's aftermath saw a rapid acceleration in radar equipment production for the Pacific Fleet. Every major American warship would receive fire control radar systems within 6 months. The technological advantage demonstrated at Leyte Gulf became standard throughout the Navy. Gun Director Operator Torres cleaned and maintained his Mark 37 equipment as Washington continued shore bombardment operations. The same radar system that had destroyed Japanese cruisers now supported American infantry advancing inland. Technology served both offensive and defensive purposes with equal effectiveness. Japanese naval intelligence analyzed survivor reports from the destroyed cruisers with growing alarm. American ships could engage targets with devastating accuracy in complete darkness. Traditional naval tactics were obsolete against such technological superiority. New strategies were desperately needed. The victory at Leyte Gulf validated American research and development programs that had begun years before Pearl Harbor. Investment in radar technology and fire control systems had produced weapons that gave decisive advantages to U.S. forces. Scientific superiority translated directly into military dominance. Chief Sullivan addressed his gun crews as Washington secured from the morning fire support mission. The men had witnessed the future of naval warfare during the previous night's battle. Radar-guided guns could destroy any enemy force regardless of weather or visibility conditions. American technological supremacy was absolute. Washington's performance at Leyte Gulf became a model for night fighting tactics throughout the Pacific Fleet. Training programs emphasized radar fire control procedures and electronic warfare techniques. The lessons learned during the destruction of the Japanese cruiser force spread rapidly through American naval forces. The technological revolution demonstrated at Leyte Gulf extended beyond radar systems. American ships featured superior damage control equipment, advanced communications gear, and more effective ammunition. Every aspect of naval technology favored U.S. forces over their Japanese opponents. Radar Operator Park documented his equipment's performance during the engagement for technical analysis teams. The Mark 8 fire control radar had exceeded all specifications during actual combat conditions. American electronic technology proved both reliable and devastatingly effective against enemy forces. Japanese Combined Fleet Headquarters struggled to develop countermeasures for American radar-controlled guns. Electronic jamming equipment was primitive and ineffective. Japanese ships lacked the sophisticated fire control systems needed to compete with American technology. The gap was unbridgeable with existing resources. Lieutenant Commander Harrison prepared comprehensive briefings on radar fire control tactics for other American ships. Washington's victory provided a template for future night engagements. The technological advantages would be shared throughout the Pacific Fleet to maximize their impact on Japanese forces. The destruction of Admiral Kurita's cruiser force demonstrated that Japanese naval aviation could no longer rely on surface escort protection. American radar-equipped ships could destroy Japanese vessels before airstrikes could develop effectively. The entire Japanese naval strategy required fundamental revision. Martinez climbed to Washington's lookout position to observe the transport area where thousands of American troops were landing on Leyte beaches. The successful night battle had secured the invasion force against surface attack. Japanese naval forces could no longer threaten major American operations. Turret Captain Rodriguez supervised maintenance on his 16-inch guns after their devastating performance against Japanese cruisers. The weapons had functioned perfectly under radar control. American naval gunnery had achieved a level of precision that would have been impossible just 5 years earlier. The tactical revolution demonstrated at Leyte Gulf spread rapidly through American naval doctrine. Night fighting became a preferred tactic for U.S. forces equipped with radar fire control systems. Japanese ships would avoid darkness engagements for the remainder of the Pacific War. Fire Controlman Chun compiled performance data on Washington's fire control computers for technical evaluation teams. The analog systems had calculated accurate firing solutions while tracking multiple targets simultaneously. American computational technology matched the radar revolution in importance. Japanese naval personnel who survived the cruiser destruction struggled to understand what had happened to their ships. The enemy had achieved impossible shooting accuracy in complete darkness. Many survivors believed American ships possessed supernatural abilities rather than advanced technology. Washington's victory at Leyte Gulf marked the final obsolescence of Japanese surface naval tactics. Traditional approaches to sea warfare could not compete with radar-controlled guns and computer fire control systems. The Imperial Navy's conventional forces were strategically irrelevant. Chief Williams reflected on the ammunition efficiency achieved during the night battle. Washington had destroyed 3 major warships using less than 10% of her ammunition load. Radar fire control eliminated the wasteful shooting that had characterized earlier naval engagements. The psychological impact of technological superiority extended beyond immediate tactical advantages. Japanese naval officers understood that their forces could not compete with American electronic warfare capabilities. This knowledge undermined confidence and fighting effectiveness throughout the Imperial Navy. Admiral Lee's final report on the Leyte Gulf engagement emphasized the decisive nature of American technological advantages. Radar fire control systems had revolutionized naval warfare in a single night. Japanese surface forces were no longer capable of challenging American naval supremacy. Gun crews throughout Washington discussed the remarkable accuracy achieved against Japanese targets. Veterans of earlier battles had never witnessed such precise shooting in darkness. The radar-guided guns had performed beyond the most optimistic expectations of their designers. The technological lessons from Leyte Gulf influenced American naval strategy for the remainder of the Pacific War. Night engagements became preferred tactics for U.S. forces. Japanese ships would avoid darkness whenever possible. The revolution in naval warfare was complete and permanent. Lieutenant Thompson completed his comprehensive analysis of Washington's gunnery performance for Naval War College evaluation. The battle had demonstrated that radar fire control systems provided overwhelming advantages in surface combat. Traditional naval tactics were permanently obsolete. Japanese Admiral Toyota received reports of the cruiser force destruction with deep concern. American technological superiority had eliminated conventional surface warfare as a viable option. The Imperial Navy would be forced to rely increasingly on suicide attacks and unconventional tactics. Washington anchored in Leyte Gulf as the sun set on October 26, 1944. The previous night's battle had demonstrated American naval supremacy in the starkest possible terms. Radar-controlled guns had achieved what seemed impossible just years earlier. The technological revolution was complete. Martinez stood watch on Washington's signal bridge as darkness returned to the Pacific. The same darkness that had concealed Japanese cruisers now protected American forces equipped with radar. Technology had reversed the traditional advantages of night fighting. The revolution would continue until Japan surrendered. The battle's impact on Japanese naval strategy was immediate and permanent. Surface forces would avoid engagements with radar-equipped American ships. Traditional naval warfare had become suicidal against technologically superior opponents. The Imperial Navy's conventional fleet was effectively eliminated. Washington's crew prepared for continued operations supporting the Leyte invasion. The ship's technological superiority would be applied to shore bombardment and escort duties. Radar fire control systems proved equally effective against land and sea targets. American electronic warfare dominated every aspect of Pacific combat. Chief Sullivan secured his 5-inch guns as Washington prepared for the next day's operations. The weapons that had destroyed Japanese cruisers would support American infantry advancing inland. Technology served all aspects of naval warfare with devastating effectiveness. The victory at Leyte Gulf validated every aspect of American investment in radar technology and fire control systems. Years of research and development had produced weapons that gave decisive advantages to U.S. forces. Scientific superiority translated directly into military dominance throughout the Pacific theater. Radar operator Kim powered down his equipment as Washington secured from general quarters. The technology that had seemed magical to Japanese observers was becoming routine for American crews. Training and equipment combined to create overwhelming advantages that would persist until the war's end. Japanese naval intelligence analyzed the Leyte Gulf disaster with growing desperation. American radar technology had eliminated conventional surface warfare as a viable option. New tactics were desperately needed, but technological limitations made effective countermeasures impossible. The destruction of Admiral Kurita's cruiser force marked a turning point in Pacific naval warfare. American technological superiority was now absolute and decisive. Japanese surface forces could no longer challenge U.S. naval operations effectively. The revolution was complete and irreversible. Washington's performance at Leyte Gulf became legendary throughout the Pacific Fleet. The ship had demonstrated that American technology could achieve seemingly impossible results against determined enemies. Radar-controlled guns had revolutionized naval warfare in a single devastating engagement. Fire Control Officer Thompson reviewed his battle damage assessment as Washington prepared for continued operations. The ship had suffered no casualties and minimal damage while destroying 3 enemy heavy cruisers. American technological superiority had achieved perfect results. The tactical implications of radar fire control extended far beyond the immediate battle. American ships could now engage enemy forces at extreme ranges in any weather conditions. Japanese naval doctrine was permanently obsolete against such technological advantages. Martinez observed the peaceful scene in Leyte Gulf as hundreds of American ships continued their operations. The successful night battle had eliminated the last serious threat to the invasion force. Japanese naval power was broken by American technological superiority. The psychological impact on Japanese naval personnel was severe and lasting. Traditional fighting methods could not compete with radar-controlled guns. Many officers questioned whether conventional resistance remained viable against such overwhelming technological advantages. Washington's ammunition expenditure during the battle demonstrated the efficiency of radar fire control. The ship had achieved maximum destruction with minimum waste. Technology eliminated the inaccurate shooting that had characterized earlier naval engagements. Chief Williams completed his post-battle inspection of Washington's magazines and handling equipment. All systems had functioned perfectly during the engagement. American naval technology proved both reliable and devastatingly effective against enemy forces. The victory at Leyte Gulf validated American industrial superiority over Japanese manufacturing capabilities. Radar equipment and fire control systems represented technological advances that Japan could not match or counter effectively. The gap would only widen as the war continued. Turret Captain Rodriguez supervised routine maintenance on his 16-inch guns after their spectacular performance against Japanese cruisers. The weapons had exceeded all expectations under radar control. American naval gunnery had achieved unprecedented levels of accuracy and effectiveness. Japanese survivors of the cruiser destruction struggled to explain their defeat to intelligence officers. The enemy had achieved impossible shooting accuracy in complete darkness. Many believed supernatural forces rather than advanced technology were responsible for their ship's destruction. The technological revolution demonstrated at Leyte Gulf spread rapidly through American forces in the Pacific. Training programs emphasized electronic warfare techniques and radar fire control procedures. The advantages would be maximized throughout the fleet. Gun Director Operator Torres cleaned his Mark 37 equipment as Washington continued shore bombardment operations. The same radar system that had destroyed Japanese cruisers now supported American troops advancing inland. Technology served all aspects of naval warfare. Admiral Lee's action report reached Washington, D.C. within a week of the battle. Navy Department officials immediately recognized the significance of the technological demonstration. Radar fire control had revolutionized naval warfare permanently. The destruction of the Japanese cruiser force eliminated surface threats to American amphibious operations throughout the Pacific. Radar-equipped ships could protect invasion forces against any conventional naval attack. Japanese surface warfare capabilities were strategically neutralized. Lieutenant Commander Harrison analyzed the battle's electronic warfare aspects for intelligence evaluation teams. American radar technology had provided complete dominance over Japanese forces equipped with traditional optical systems. The technological advantage was overwhelming and decisive. Washington's crew took justifiable pride in their demonstration of American technological superiority. The ship had proved that radar fire control could eliminate any surface threat regardless of enemy skill or determination. Technology had overcome traditional military virtues. Fire Controlman Chin documented his radar equipment's flawless performance for technical analysis teams. The Mark 8 system had tracked multiple targets while computing accurate firing solutions. American electronic technology exceeded all design specifications under combat conditions. The battle's aftermath saw immediate acceleration in radar equipment production for Pacific Fleet units. Every American warship would receive fire control systems within months. The technological advantage demonstrated at Leyte Gulf became standard throughout the Navy. Japanese Combined Fleet headquarters struggled to develop new tactics against radar-controlled American guns. Traditional naval warfare was obsolete against such technological superiority. Conventional surface forces could no longer challenge U.S. naval operations effectively. Martinez watched the sunrise on October 27, 1944 from Washington's Signal Bridge. The previous night's technological demonstration had secured American naval supremacy permanently. Japanese surface forces would avoid future engagements with radar-equipped ships. The victory at Leyte Gulf marked the end of the Imperial Japanese Navy as an effective conventional force. Radar technology had eliminated surface warfare as a viable option for Japanese commanders. The technological revolution was complete and irreversible. Chief Sullivan addressed his gun crews as Washington secured from morning fire support operations. The men had witnessed the future of naval combat during the previous night's engagement. American technological superiority would dominate every aspect of Pacific warfare. Washington's performance at Leyte Gulf became the model for American naval tactics throughout the remainder of the Pacific War. Radar fire control systems provided decisive advantages that Japanese forces could not counter effectively. The revolution in naval warfare was permanent. The technological demonstration at Leyte Gulf validated years of American investment in research and development programs. Electronic warfare capabilities had produced weapons that gave overwhelming advantages to U.S. forces. Scientific superiority translated directly into military dominance. Radar Operator Park secured his equipment as Washington anchored in the transport area. The technology that had achieved seemingly impossible results was becoming routine for American crews. Training and equipment combined to create unbeatable advantages. Japanese naval aviation received reports of the cruiser destruction with alarm. Surface escorts could no longer provide effective protection against radar-equipped American ships. The entire structure of Japanese naval operations required fundamental revision. The psychological impact of technological superiority extended throughout the Japanese fleet. Naval personnel understood that conventional tactics were useless against American electronic warfare capabilities. This knowledge undermined confidence and fighting effectiveness permanently. Gun crews throughout Washington discussed the remarkable shooting performance achieved against Japanese targets. The radar-guided guns had hit invisible enemies with mathematical precision. Technology had transformed naval warfare beyond recognition. Lieutenant Thompson prepared comprehensive briefings on radar fire control tactics for distribution throughout the Pacific Fleet. Washington's victory provided proven methods for destroying enemy forces with minimal risk. The technological advantages would be shared fleet-wide. The destruction of Admiral Kurita's cruiser force demonstrated that Japanese naval strategy required complete revision. Conventional surface warfare was suicidal against technologically superior American forces. New approaches were desperately needed but technologically impossible. Fire Control Officer Thompson completed his final analysis of Washington's gunnery performance for Naval War College evaluation. The battle had proved that radar technology provided overwhelming advantages in all aspects of surface combat. Traditional naval warfare was permanently obsolete. Washington's crew prepared for continued operations in support of the Leyte invasion. The ship's technological superiority would be applied to all aspects of naval warfare. Radar fire control systems dominated every engagement type from surface combat to shore bombardment. The victory at Leyte Gulf on the night of October 25, 1944 marked the moment when American technological superiority became absolute and decisive in Pacific naval warfare. Japanese surface forces could no longer challenge radar-equipped ships effectively. The revolution was complete and would determine the war's outcome. The weeks following the night battle saw Washington continue her operations in support of the Leyte invasion. Her radar fire control systems proved equally devastating against shore targets as they had been against Japanese cruisers. The Mark 8 fire control radar could plot the coordinates of enemy positions miles inland with precision that amazed even veteran artillery observers. Lieutenant Colonel Frank Mitchell commanded the 32nd Infantry Regiment advancing toward Ormoc on Leyte's western coast. His troops encountered fierce resistance from Japanese defensive positions in the hills overlooking the coastal plain. Standard artillery support was limited by the mountainous terrain and poor visibility caused by tropical weather conditions. Washington's 16-inch guns provided the solution to the infantry's problem. The battleship anchored 12,000 yards offshore could engage targets 25 miles inland using her radar fire control system. Each 2,700-pound shell could demolish a concrete bunker or eliminate an entire squad of defenders. The psychological impact on Japanese troops was enormous. Fire Control Officer Thompson coordinated shore bombardment missions from Washington's main battery plotting room. The ship received target coordinates from forward artillery observers equipped with radio sets. The Mark 8 radar system could plot these positions with accuracy measured in yards rather than hundreds of yards achieved by conventional artillery. Japanese defenders in the hills above Ormoc had never experienced naval gunfire of this intensity and precision. Their concrete fortifications had been designed to resist 105 mm and 155 mm artillery shells. Washington's 16-inch projectiles penetrated these positions as easily as they had penetrated Japanese cruiser armor during the night battle. Corporal Jimmy Walsh served as a forward artillery observer with the 32nd Infantry Regiment. His job was to spot enemy positions and call in fire support from offshore naval units. Walsh had worked with destroyers and cruisers during earlier Pacific campaigns. But Washington's firepower was unlike anything he had experienced. The battleship could deliver a 9-gun salvo of 16-inch shells on target within 90 seconds of receiving coordinates. Each salvo dropped 24,300 pounds of high explosive on an area the size of a football field. Japanese defensive positions disappeared completely under this bombardment. Secondary explosions indicated ammunition storage areas were being destroyed. Major General Franklin Siebert commanded the X-Corps advancing across Leyte toward Japanese strongholds in the island's mountainous interior. His infantry divisions had been slowed by determined enemy resistance and difficult terrain. Washington's fire support changed the tactical equation dramatically. The battleship's radar-controlled guns could engage targets that conventional artillery could not reach. Japanese positions on reverse slopes and in deep valleys were vulnerable to plunging fire from the 16-inch projectiles. The shells followed high arcing trajectories that brought them down almost vertically onto enemy positions. Gun Director Operator Torres adapted his Mark 37 fire control system for shore bombardment missions. The 5-inch guns proved highly effective against personnel targets and light fortifications. The rapid fire capability allowed sustained bombardment of wide areas. Japanese troops could not remain in their positions under such intense fire. Admiral Oldendorf commanded the bombardment group supporting the Leyte invasion. His task force included 6 battleships, 8 cruisers, and 18 destroyers. But Washington's radar fire control systems gave her capabilities that exceeded the combined firepower of the other ships. Technology had revolutionized naval gunfire support. The effectiveness of radar-controlled naval gunfire extended beyond immediate destruction of enemy positions. Japanese commanders could no longer predict where American fire would fall. Traditional counter-battery tactics were useless against guns that could engage targets beyond visual range with computer precision. Captain Harold Davis commanded the destroyer USS Fletcher operating inshore of Washington during shore bombardment missions. His ship provided close fire support for landing forces while the battleship engaged distant targets. The coordination between radar-equipped ships was seamless and devastatingly effective. Fletcher's 5-inch guns used the same Mark 37 fire control system that had proved so effective during Washington's night battle with Japanese cruisers. The destroyer could engage multiple targets simultaneously while maintaining accurate fire on all positions. Japanese defenders faced a technological storm they could not comprehend or counter. The psychological impact of precision naval gunfire spread throughout Japanese forces defending Leyte. Soldiers who survived Washington's bombardments described shells that seemed guided by supernatural forces. They did not understand that American radar technology made such accuracy possible in all weather conditions. Staff Sergeant Michael O'Brien led an infantry squad advancing through terrain that had been bombarded by Washington's 16-inch guns. The destruction was unlike anything he had seen during 2 years of Pacific fighting. Japanese positions had been obliterated so completely that few traces remained of the defenders. The technological advantage demonstrated during the night battle with Japanese cruisers translated directly into overwhelming superiority in shore bombardment missions. Enemy defensive positions that might have held up American advances for weeks were eliminated in minutes by radar-controlled gunfire. Japanese General Yamashita commanded the 14th Area Army defending the Philippines. His reports to Imperial General Headquarters described the hopeless situation facing Japanese forces against American technological superiority. Conventional defensive tactics were useless against radar-guided naval guns. Washington's crew adapted quickly to shore bombardment operations after their spectacular success in surface combat. The same radar systems and fire control computers that had destroyed Japanese cruisers now supported American infantry advancing across difficult terrain. Technology served all aspects of naval warfare. Commander Robert Reynolds served as Washington's gunnery officer during the Leyte campaign. His analysis of the ship's performance showed that radar fire control had increased accuracy by 400% compared to optical systems. The technological revolution had transformed naval warfare permanently. Fire Controlman Chun monitored his radar equipment during a typical shore bombardment mission. The Mark 8 system tracked multiple targets simultaneously while computing firing solutions for each position. American infantry could call for fire support against any enemy position within range of the battleship's guns. Japanese artillery positions in the hills above Leyte posed a serious threat to American landing forces until Washington's radar-controlled guns eliminated them. The battleship could engage enemy batteries at ranges where Japanese guns could not return effective fire. Counter-battery duels became one-sided affairs. The tactical revolution initiated during the night battle with Japanese cruisers continued throughout the Leyte campaign. American forces equipped with radar technology dominated every aspect of combat operations. Japanese defenders could only delay the inevitable advance toward final defeat. Chief Gunners Mate Williams supervised ammunition handling during sustained shore bombardment operations. Washington fired more than 1,000 rounds of 16-inch ammunition during the first week of the Leyte campaign. Each shell was guided to its target by radar and computer with devastating accuracy. The efficiency of radar-controlled gunfire amazed military observers from other Allied nations. British and Australian officers studied Washington's fire control systems to understand how American technology had achieved such remarkable results. The lessons would influence post-war naval development. Lieutenant Commander Harrison coordinated fire support missions from Washington's Combat Information Center. The CIC had become the nerve center of modern naval warfare. Radar scopes and plotting tables provided complete tactical information to the ship's commanders. Japanese forces lacked equivalent capabilities. Japanese survivors of Washington's bombardments struggled to describe their experiences to intelligence officers. The enemy had achieved impossible shooting accuracy against positions they could not possibly see. Many defenders believed American forces possessed magical abilities rather than advanced technology. The destruction of Japanese defensive positions on Leyte proceeded with mechanical efficiency. Washington's radar-controlled guns eliminated enemy strongpoints one by one until organized resistance collapsed. American technological superiority had made traditional defensive warfare obsolete. Gun crews aboard Washington took pride in their contribution to the infantry's advance across Leyte. The same weapons that had destroyed Japanese cruisers during the night battle now supported American soldiers fighting house to house in Filipino villages. Technology served both strategic and tactical purposes. Major Thomas Henderson commanded a battalion of the 32nd Infantry Regiment advancing toward Ormoc. His troops had learned to coordinate their movements with Washington's fire support missions. The battleship could clear enemy positions minutes before infantry attacks began. Casualties dropped dramatically. The coordination between radar-equipped ships and ground forces represented a new form of combined arms warfare. American commanders could concentrate overwhelming firepower against specific targets while minimizing collateral damage to friendly forces. Japanese defenders had no countermeasures for such precision. Radar operator Park tracked Japanese troop movements from his position in Washington's Combat Information Center. The ship's radar could detect large formations moving behind enemy lines. This intelligence allowed American commanders to plan attacks against concentrations of Japanese forces. The technological advantages demonstrated at Leyte Gulf spread throughout American forces in the Pacific. Training programs emphasized radar fire control procedures and electronic warfare techniques. The gap between American and Japanese capabilities widened with each passing month. Admiral Halsey visited Washington during the Leyte campaign to observe radar fire control operations firsthand. The Third Fleet commander immediately recognized the revolutionary impact of the technology. Every major American warship would receive similar equipment within months. Fire Control Officer Thompson briefed Admiral Halsey on Washington's capabilities during shore bombardment operations. The battleship could engage targets throughout Leyte using radar-controlled guns. Japanese forces had no sanctuary from American firepower. The technological advantage was complete and decisive. Japanese Imperial General Headquarters received increasingly desperate reports from commanders in the Philippines. American radar-controlled guns had eliminated the defensive advantages of terrain and weather. Traditional military tactics were useless against such technological superiority. Washington's performance during the Leyte campaign validated every aspect of American investment in radar technology. The system had proved equally effective against surface ships and shore targets. Versatility matched the overwhelming firepower advantages provided by computer-controlled guns. Chief Sullivan addressed his gun crews during a brief respite between fire support missions. The men had witnessed the transformation of naval warfare during their service aboard Washington. Radar-guided guns could destroy any target regardless of range, weather, or visibility conditions. The psychological impact of technological superiority extended throughout Japanese forces in the Pacific. Reports of Washington's capabilities spread among enemy units facing American attacks. Many defenders lost confidence in their ability to resist technologically superior opponents. Turret Captain Rodriguez supervised routine maintenance on his 16-inch guns after another day of shore bombardment operations. The weapons had fired 45 rounds during the morning mission. Each shell had been guided to its target by radar with computer precision. Ammunition efficiency was remarkable. Japanese General Suzuki commanded the 35th Army defending central Leyte against American advances. His forces faced an impossible situation against enemies equipped with radar-controlled naval guns. Defensive positions that had taken months to construct were destroyed in minutes. The tactical lessons learned during Washington's night battle with Japanese cruisers applied directly to shore bombardment operations. Radar fire control provided the same overwhelming advantages against land targets that it had demonstrated against surface ships. Technology dominated every aspect of warfare. Lieutenant Thompson compiled detailed reports on Washington's gunnery performance for Naval War College analysis. The battleship had achieved unprecedented accuracy rates during both surface and shore bombardment operations. Radar technology had revolutionized naval warfare permanently. Fire Controlman Chin documented his equipment's performance during weeks of continuous operations supporting the Leyte invasion. All radar systems had functioned flawlessly under combat conditions. American electronic technology proved both reliable and devastatingly effective. The success of radar-controlled gunfire influenced American strategy throughout the Pacific War. Night operations became preferred tactics for forces equipped with electronic warfare capabilities. Japanese ships and shore installations were vulnerable to around-the-clock attacks. Gun Director Operator Torres adapted his Mark 37 system for night shore bombardment missions. The 5-inch guns could engage enemy positions in complete darkness with the same accuracy achieved during daylight operations. Weather and visibility had become irrelevant factors in naval warfare. Japanese defensive doctrine had emphasized using darkness and weather to limit American firepower advantages. Radar technology eliminated these traditional defensive benefits. Enemy positions were equally vulnerable to precision bombardment under all conditions. Washington's crew worked around the clock supporting American forces advancing across Leyte. The ship's radar-controlled guns provided continuous fire support for infantry operations. Technology had created capabilities that seemed impossible just years earlier. Chief Williams supervised ammunition replenishment operations as Washington anchored in Leyte Gulf. The battleship had expended enormous quantities of ammunition during the campaign. Each shell had been guided to its target with radar precision. Waste was eliminated through technological superiority. The coordination between Washington and other radar-equipped ships created a network of overlapping fire support zones. American forces could call for precision bombardment from multiple platforms simultaneously. Japanese defenders faced overwhelming firepower concentration. Admiral Kinkaid commanded the 7th Fleet supporting MacArthur's Philippines campaign. His forces included dozens of ships equipped with radar fire control systems. The technological advantage over Japanese defenders was complete and decisive. Seaman Martinez observed the controlled destruction of Japanese positions from Washington's signal bridge. The battleship's guns methodically eliminated enemy strongpoints one by one. Each target was engaged with computer-calculated precision. Human error was eliminated from the gunnery equation. The technological revolution that began with Washington's night battle victory continued throughout the Pacific War. Radar-equipped American ships dominated every engagement with Japanese forces. Traditional naval and coastal defense tactics became obsolete overnight. Japanese naval aviation attempted to counter American radar advantages through mass kamikaze attacks. But Washington's 5-inch guns could track and destroy incoming aircraft with the same precision they had demonstrated against surface targets. Technology provided defensive as well as offensive capabilities. Lieutenant Commander Harrison coordinated air defense operations from Washington's Combat Information Center during kamikaze attacks on the Leyte invasion force. The ship's radar systems could track dozens of incoming aircraft simultaneously while directing defensive fire from all gun mounts. The Mark 37 fire control system that had destroyed Japanese cruisers proved equally effective against suicide aircraft. Washington's 5-inch guns could engage multiple targets simultaneously while maintaining devastating accuracy against individual planes. Few kamikaze aircraft penetrated the radar-controlled defensive fire. Fire Control Officer Thompson analyzed Washington's air defense performance during major kamikaze attacks. The battleship had shot down 23 enemy aircraft during a single day of operations. Radar-controlled guns achieved hit rates that would have been impossible with optical fire control systems. Japanese kamikaze pilots discovered that American radar technology had eliminated the traditional advantages of mass attacks. Individual aircraft could be tracked and engaged at maximum range. The element of surprise was lost against enemies equipped with electronic detection systems. Washington's defensive capabilities matched her offensive firepower advantages. The same radar systems that guided shells against enemy ships and shore positions could direct anti-aircraft fire with equal precision. Technology provided comprehensive military superiority. Gun crews aboard Washington trained continuously on radar fire control procedures during brief respites between combat operations. Proficiency with electronic systems required constant practice and maintenance. Technology alone was insufficient without skilled operators. The psychological impact of radar-controlled anti-aircraft fire demoralized Japanese pilots attempting kamikaze attacks. Their aircraft were engaged at impossible ranges by guns that seemed to track every movement. Many pilots reported that resistance appeared futile against such technological superiority. Admiral Nimitz visited the Pacific Fleet units operating off Leyte to observe radar fire control systems in action. The Pacific Fleet commander immediately recognized that technology had revolutionized naval warfare permanently. American industrial superiority was translating into overwhelming military advantages. Washington's performance during air defense operations demonstrated the versatility of radar fire control technology. The same systems that had destroyed Japanese cruisers and shore installations could eliminate incoming aircraft with equal effectiveness. Multi-role capability was a major advantage. Japanese Combined Fleet Headquarters analyzed reports of American radar capabilities with growing desperation. Traditional naval aviation tactics were obsolete against enemies equipped with electronic detection and fire control systems. New strategies were needed but technologically impossible to implement. Chief Sullivan supervised his gun crews during intense anti-aircraft operations as Washington defended the Leyte anchorage against kamikaze attacks. The 5-inch guns fired continuously for 3 hours while radar systems tracked incoming Japanese aircraft. Not a single enemy plane reached the transport area. The effectiveness of radar-controlled defensive fire influenced Japanese strategy throughout the remainder of the Pacific War. Mass kamikaze attacks were abandoned in favor of small-scale infiltration tactics. American technological superiority had eliminated conventional air attack methods. Fire Controlman Chun monitored his radar scopes during the largest kamikaze attack attempted against American forces at Leyte. More than 200 Japanese aircraft approached the invasion fleet in waves. Washington's radar systems tracked every plane while directing defensive fire from multiple gun mounts. The coordination between radar-equipped ships created an impenetrable defensive network around American invasion forces. Japanese aircraft faced concentrated fire from dozens of computer-controlled gun mounts. Few planes survived to reach their targets. Technology had revolutionized air defense. Radar operator Park documented his equipment's performance during major air battles off Leyte. The Mark 8 radar system had tracked more than 300 individual aircraft during a single day of operations. American electronic technology exceeded all design specifications under extreme combat conditions. Japanese pilots who survived encounters with radar-controlled anti-aircraft fire reported that American guns seemed to predict their movements. They did not understand that computer fire control systems calculated interception courses continuously. Technology appeared magical to enemies who lacked equivalent capabilities. Washington's crew took pride in their air defense achievements during the Leyte campaign. The battleship had shot down more enemy aircraft than many specialized anti-aircraft cruisers. Radar fire control systems provided capabilities that traditional optical equipment could not match. Lieutenant Thompson prepared comprehensive analysis of Washington's multi-role performance for Pacific Fleet Headquarters. The battleship had proved equally effective against surface ships, shore targets, and aircraft. Radar technology provided unprecedented versatility in naval warfare. The tactical implications of radar-controlled guns extended far beyond individual engagements. American forces could now dominate sea, land, and air operations using integrated electronic warfare systems. Japanese defenders faced technological superiority in every aspect of combat. Gun Director Operator Torres reflected on his experiences operating the Mark 37 fire control system during months of continuous combat operations. The equipment had functioned flawlessly under all conditions while guiding thousands of rounds to their targets with computer precision. Japanese intelligence services struggled to understand American radar technology through analysis of captured equipment and prisoner interrogations. The technological gap was too great to bridge with existing Japanese industrial capabilities. Scientific superiority was determining the war's outcome. Admiral Lee prepared his final report on Washington's performance during the Leyte campaign for submission to Navy Department headquarters. The battleship had demonstrated that radar fire control technology provided decisive advantages in all forms of naval warfare. Washington's revolutionary capabilities during the Leyte campaign influenced American naval strategy for the remainder of the Pacific War. Every major operation would feature radar-equipped ships providing fire support for amphibious invasions. Technology had created new possibilities for projecting military power. The victory at Leyte Gulf and the subsequent campaign demonstrated that American technological superiority was absolute and irreversible. Japanese forces could not compete with radar-controlled guns and computer fire control systems. The revolution in naval warfare was complete and would determine the final outcome of the Pacific War. The strategic implications of Washington's technological demonstration extended far beyond the immediate tactical victories achieved during the Leyte campaign. American naval planners recognized that radar fire control systems had fundamentally altered the nature of warfare in the Pacific theater. Traditional Japanese defensive strategies were obsolete against enemies equipped with electronic detection and computer-controlled weapons. Captain William Callahan served as a naval intelligence officer analyzing Japanese responses to American radar technology. His reports to Pacific Fleet headquarters documented the rapid deterioration of enemy morale throughout the Imperial Navy. Japanese commanders understood that conventional tactics could not compete with American technological advantages. The psychological warfare aspects of radar-controlled gunfire proved as devastating as the physical destruction inflicted on enemy forces. Japanese soldiers and sailors who survived encounters with Washington's weapons described experiences that seemed to defy natural laws. Shells appeared to be guided by invisible forces that could see through darkness and weather. Rear Admiral Morton Deo commanded Cruiser Division 7 during operations supporting the Leyte invasion. His ships received radar fire control systems based on technology demonstrated by Washington during the night battle with Japanese cruisers. The advantages proved equally decisive when applied to smaller vessels. The heavy cruiser USS Louisville, equipped with Mark 8 radar, achieved accuracy rates that exceeded Washington's already remarkable performance. The cruiser's 8-inch guns could engage targets at 18,000 yards with computer precision. Japanese defensive positions faced destruction from ranges that seemed impossible with conventional fire control methods. Lieutenant Colonel James Bradley commanded a Marine artillery battalion providing fire support for infantry operations on Leyte. His 155mm howitzers worked in coordination with Washington's naval guns to create overlapping fields of fire. The combination of land-based and ship-based radar-controlled weapons eliminated any sanctuary for Japanese defenders. The integration of naval and ground-based fire control systems represented a new level of combined arms warfare. American commanders could concentrate devastating firepower from multiple platforms against specific targets while maintaining precise coordination between different weapon systems. Technology had created capabilities that revolutionized military operations. Staff Sergeant Robert Kowalski served as a forward observer coordinating fire support between Washington and Marine artillery units. His radio equipment allowed instant communication between ship and shore-based fire control centers. Target coordinates could be shared instantaneously between radar-equipped weapon systems. Japanese defensive positions that had withstood weeks of conventional bombardment were eliminated within minutes when subjected to coordinated radar-controlled fire. The precise timing and accuracy of American weapons created cumulative effects that exceeded the sum of individual platforms. Technology enabled unprecedented coordination between military forces. The technological revolution initiated by Washington's victory at Leyte Gulf influenced American industrial production throughout the remainder of the war. Factories dedicated to radar equipment manufacturing operated around the clock to meet demand from Pacific Fleet units. Every major American warship would receive fire control systems within 6 months. Commander Harold Sconland supervised the installation of Mark 37 fire control systems aboard destroyers and escort vessels during the Leyte campaign. His technical teams worked continuously to equip smaller ships with radar-guided weapons. The technological advantage would be extended throughout the American fleet. Japanese naval intelligence services attempted to develop countermeasures for American radar technology through captured equipment analysis and prisoner interrogation programs. Their efforts proved futile due to the sophisticated electronic systems and manufacturing techniques required for effective radar jamming equipment. The technological gap between American and Japanese capabilities had become unbridgeable through conventional industrial methods. Washington's radar systems represented years of advanced research and development that Japan could not replicate with existing resources. Scientific superiority was determining the war's strategic direction. Chief Electronics Technician Michael Sullivan maintained Washington's radar equipment during continuous combat operations off Leyte. His expertise with complex electronic systems ensured maximum performance from the ship's fire control computers. Technical proficiency proved as important as tactical skill in exploiting technological advantages. The reliability of American radar technology under extreme combat conditions amazed military observers from allied nations. British and Australian naval officers studied Washington's systems to understand manufacturing techniques and operational procedures. Post-war naval development would be influenced by American technological innovations. Captain Thomas Gatch commanded the battleship USS South Dakota during shore bombardment operations supporting the Leyte invasion. His ship received radar fire control upgrades based on Washington's successful systems. The technological advantages proved equally effective when applied to other battleship classes. South Dakota's 16-inch guns achieved accuracy rates that matched Washington's performance during the night battle with Japanese cruisers. Radar-controlled fire eliminated the variability associated with human error in optical fire control systems. Computer calculations provided consistent precision under all conditions. The standardization of radar fire control throughout the Pacific Fleet created unprecedented capabilities for American naval forces. Multiple ships could engage the same target simultaneously while maintaining precise coordination through electronic communication systems. Japanese defenders faced concentrated firepower that seemed impossibly coordinated. Lieutenant Commander George Stevens served as Washington's communications officer during the Leyte campaign. His radio equipment linked the battleship to other radar-equipped vessels throughout the invasion fleet. Target information could be shared instantaneously between ships engaging enemy positions. The network effects created by radar-equipped ships communicating through secure radio channels multiplied the effectiveness of individual platforms. American commanders possessed real-time tactical information that allowed optimal deployment of available firepower. Japanese forces faced enemies with perfect battlefield awareness. Major General Curtis LeMay visited Washington during the Leyte campaign to observe coordination between naval gunfire and Army Air Force's bombing operations. The integration of radar-controlled weapons with aerial bombardment created synergistic effects that devastated Japanese defensive positions. Washington's radar systems could track incoming American aircraft while simultaneously engaging enemy targets with naval gunfire. The precise coordination prevented friendly fire incidents while maximizing destruction inflicted on Japanese positions. Technology enabled unprecedented cooperation between military services. The tactical flexibility provided by radar fire control systems allowed American commanders to adapt quickly to changing battlefield conditions. Washington could shift from shore bombardment to air defense to surface combat within minutes. Japanese forces faced enemies with capabilities that seemed limitless. Fire control technician First Class Anthony Romano maintained the analog computers that calculated firing solutions for Washington's main battery during the Leyte campaign. His expertise with mechanical computation systems ensured accurate fire control under all conditions. Human skill remained essential despite technological advances. The complexity of radar fire control systems required extensive training programs for American naval personnel. Washington's crew had spent months mastering electronic warfare techniques before achieving the proficiency demonstrated during combat operations. Technology alone was insufficient without skilled operators. Japanese prisoners captured during the Leyte campaign described the psychological impact of facing radar-controlled weapons. Enemy fire seemed to possess supernatural accuracy that defied conventional understanding of ballistics and gunnery. Many defenders believed American forces had magical abilities. The demoralization of Japanese forces extended throughout the imperial military as reports of American technological superiority spread among enemy units. Traditional military virtues of courage and determination appeared inadequate against technologically superior opponents. Morale collapsed as the hopelessness of resistance became apparent. Admiral William Halsey analyzed the strategic implications of radar technology for future Pacific operations. His Third Fleet would incorporate lessons learned from Washington's success into planning for subsequent amphibious invasions. Technology had created new possibilities for projecting American military power. The speed and efficiency of American advances during the Leyte campaign reflected the decisive advantages provided by radar-controlled weapons. Japanese defensive positions that might have delayed American forces for months were eliminated within days. Technology had accelerated the pace of military operations. Washington's performance during extended combat operations demonstrated the durability and reliability of American radar systems. Continuous use under extreme conditions had not degraded the accuracy or effectiveness of the ship's fire control equipment. Manufacturing quality matched technological sophistication. Chief Radioman Peter Anderson operated Washington's communication systems during coordination with other radar-equipped ships. His expertise with secure radio protocols ensured effective information sharing between vessels engaging enemy targets. Electronic warfare required new forms of military communication. The integration of radar detection with fire control systems created capabilities that transformed naval warfare fundamentally. Washington could engage multiple targets simultaneously while tracking additional threats and coordinating with other ships. Multitasking abilities exceeded human limitations through technological assistance. Japanese Admiral Ozawa received reports of American radar capabilities with deep concern for the future of the Imperial Navy. Traditional naval tactics were obsolete against enemies equipped with electronic detection and computer-controlled weapons. Fundamental strategic revision was required but technologically impossible. The cascading effects of technological superiority influenced every aspect of the Pacific War. American forces equipped with radar systems dominated land, sea, and air operations while Japanese defenders faced overwhelming disadvantages in all forms of combat. Scientific advancement was determining military outcomes. Washington's crew worked continuously during the Leyte campaign to maintain their technological edge over enemy forces. Regular maintenance and calibration of radar systems ensured maximum performance under combat conditions. Technical excellence required constant attention to detail. The lessons learned from Washington's success influenced American naval doctrine for decades beyond the end of World War II. Radar fire control became standard equipment for all major warships while electronic warfare techniques were incorporated into officer training programs. Technology had permanently changed naval operations. Lieutenant Thompson completed his comprehensive analysis of radar fire control effectiveness for submission to the Naval War College. Washington's performance data would influence future research and development programs for American naval weapons. Scientific advancement continued through systematic study of combat results. The economic implications of American technological superiority extended beyond immediate military advantages. Industrial capacity dedicated to radar production created lasting benefits for post-war economic development. Scientific research conducted during wartime laid foundations for future technological advancement. Japanese industrial leaders recognized that their nation lacked the scientific infrastructure necessary to compete with American technological capabilities. The educational and research institutions required for advanced electronics development did not exist within the Japanese Empire. Cultural and structural limitations prevented effective response. Washington's revolutionary performance during the Leyte campaign validated American investment in scientific research and technological development. Universities and private laboratories had contributed innovations that provided decisive military advantages. Academic excellence translated directly into battlefield superiority. The international implications of American radar technology influenced post-war diplomatic relationships throughout the Pacific region. Nations allied with the United States gained access to advanced military capabilities while potential enemies faced overwhelming technological disadvantages. Scientific leadership created lasting strategic benefits. Fire Control Officer Thompson reflected on the transformation of naval warfare witnessed during his service aboard Washington. Traditional skills remained important, but electronic systems had become the decisive factor in modern combat. Professional military education would require fundamental revision to address technological change. The human dimension of technological warfare remained significant despite the overwhelming advantages provided by radar systems. Washington's crew had demonstrated exceptional skill in operating complex equipment under extreme combat conditions. Technology amplified human capabilities rather than replacing them entirely. Japanese survivors of encounters with Washington's radar-controlled weapons struggled to explain their experiences to intelligence officers and military historians. The precision and coordination of American fire seemed to exceed human limitations. Technology had created capabilities that appeared supernatural to enemies who lacked equivalent systems. The strategic balance in the Pacific theater shifted decisively in favor of American forces following the demonstration of radar fire control capabilities at Leyte Gulf. Japanese military leaders understood that conventional resistance was futile against technologically superior opponents. Alternative strategies were required but limited by available resources. Washington's success influenced American planning for subsequent operations throughout the Pacific War. Every major amphibious invasion would feature radar-equipped ships providing fire support for landing forces. Technology had created new paradigms for military operations that would persist for decades. The concluding phase of the Leyte campaign demonstrated the complete integration of radar technology into American military operations. Land, sea, and air forces coordinated through electronic communication systems to achieve overwhelming superiority over Japanese defenders. Technology had unified previously separate military capabilities. Admiral Nimitz prepared his final assessment of the Leyte operation for submission to the Joint Chiefs of Staff in Washington. The campaign had proved that American technological advantages were decisive in determining the outcome of Pacific operations. Scientific superiority guaranteed ultimate victory in the war against Japan. The revolution in naval warfare initiated by Washington's night battle victory at Leyte Gulf on October 25, 1944 continued to influence military operations until Japan's surrender 11 months later. Radar-controlled weapons had made traditional naval tactics obsolete while creating new possibilities for projecting American military power throughout the Pacific theater. Washington's crew secured their weapons and equipment as the battleship departed Leyte Gulf for operations supporting the next phase of MacArthur's Philippines campaign. The technological advantages demonstrated during the night battle and subsequent shore bombardment missions would be applied to future amphibious invasions throughout the Pacific War. The legacy of American radar technology extended far beyond World War II to influence naval warfare for generations. Electronic detection and fire control systems became standard equipment for all major warships, while the principles demonstrated by Washington's crew guided military training and doctrine development throughout the post-war era. The night battle at Leyte Gulf marked the moment when American technological superiority became absolute and irreversible in determining the outcome of the Pacific War. Japanese forces could no longer compete with radar-controlled guns and computer fire control systems. The revolution was complete and would ensure ultimate victory for the United States.